Good afternoon, everybody. Hi. Let's see where we can take this, how to scale your auditing events. So oftentimes this is us and, well, everything is fine, right? Until not everything is fine anymore. Kind of the worst case scenario probably you might run into is if you learn about the breach from the press or from your users and they complain mightily. If you're a bit more lucky, maybe somebody's just asking for ransom. Especially for your data stores, this has been more or less common that people take your data ransom and maybe they have a backup and you can buy that back, or maybe they have just deleted your data, nobody knows. Sometimes you just see it on your cloud provider's bill when somebody got your access credentials and started mining some cryptocurrency. And well, it's not very efficient, but as long as it's not your own bill, you can just do that. Sometimes you just learn about the breach after the fact, and well, not nice, but still better than most of the other cases. Or ideally, you can prove that there was no harm done. Like there was a breach, but nothing actually happened. That would be the ideal case. And we want to figure out how can we prove what has happened to our system or what hasn't happened to our system. And yeah, basically what we want to avoid is the bottom half here, where everything is on fire and you just scream, what is my problem? That is the part we don't want to get into. So, unfortunately there are no silver bullets, or luckily there are no silver bullets, otherwise we wouldn't need to be here or we wouldn't have a good or a well-paying job. So no silver bullets, but that's not the end of the world. That's actually more or less a feature. So, for the rest of the talk, if you have any questions, just ask them either online or at the end. We'll probably have enough time at the end for questions. If I run out of time or if there are too many questions, I will just tweet out the answers as well. So if you head to Slido, you can just ask your questions there. If you forget them or if you're too shy to ask in person, just post your questions and we'll get to them at the end. By the way, does anybody or has anybody figured out why I'm using that handle for Twitter and Slido and everything? It has something to do, you have it on the first slide as well. It has something to do with my name. Any guesses? Any guesses? Something with my last name? Who is old enough to remember? Anybody remembers Rod 13? Where you rotate the letters by 13? And so if you take my last name, which in German basically, or in Austrian German, where I'm from, basically means horseradish, but with one N, then this is what you get. And the nice thing about Rod 13 is if you encrypt something again, then you're back at the original, because, well, 26 letters in the alphabet, 13 times 2, you get back to the original. So that's why I'm using that for any questions. So, how can we actually figure out what is happening in our system? One very nice way to do that is Audit-D. Who is actually using Audit-D actively? And I'm not sure I can see anybody. Okay, I can see a couple of hands, but not very many. So Audit-D is the Linux auditing daemon. This is the description from the man page. Generally, you have a user space component to the auditing subsystem to actually report or show you what has been happening. And you can check that out with either AllReport to get a report or AllSearch to see all the raw logs, or you can filter them down. What you can do is you can generally see what files have been accessed, what network connections have been made, has there been any system calls, which commands were run by which users, or which security events have been triggered. Stuff like that can all be collected by Audit-D. And the general idea is you have your user space program, and your user space program is running some action, like opening a file or running a program. And then you have the system call processes for user, task, and exit. And at any one of these, when you run them, there can be an exclude rule. And once you pass through that exclude rule, then that action will be collected by the audit daemon. So basically you have some rules, and whatever passes through those rules will then be collected, and you can later on check out these security events. What this actually looks like is, let's assume we're logged in here, and let's say, no, did my session just die? Okay. Let's start fresh. So let's say we want to run the report here, and for example, here you can see we have collected in some time frame here, we have collected a bunch of things on our system. For example, we had 76 logins into our system. We have lots of failed login attempts. We'll see what has been happening there a bit later on. You can see which or how many users have been able to authenticate, how many users we have in our system. So this is just a general overview of all the security-related events that we have in our system. Where are those coming from? So we already mentioned our search, and let's start with raw. These are just the raw events. These will keep scrolling for a while, and you can see these are all the relevant events that we have been collecting over time. And how they are structured once we're done scrolling through them, because there's so many. After some time we'll be done. You can use all search, of course, to filter down or search what you're seeing there. Once you're done here, you can, for example, see here, this would be one entry. And you always have a type. The type is basically telling you what kind of event do you have. It could be you change the directory, or you opened a file, or you ran a process, or here we are aborting a daemon. Then you have the message. The message consists of two parts. Here you can see this is a Unix timestamp, and this is a unique ID. Sometimes you have unique timestamps, or you have IDs and timestamps, and they are duplicated. This is then normally when you have one call that is logging multiple actions. For example, if you open a program and it also takes some other actions or opens a port, you might have multiple actions that you're logging, and they have then the same timestamp and then same ID. And then depending on whatever action you have here, you might have different things that are being collected. So for example, you see that here this thing failed, and you have a process ID and a user ID, but not everything has a process or user ID. It depends a bit on what call you're running. You could, for example, also say we are running an all search, and we run this against success no. So only sudo all search success. If you can type English correctly, then it will even show you what it's doing. So these are all the things that failed in our audit logs. Those are still a lot of events, and also oftentimes you don't have just a single system that you want to monitor. And generally, whatever you have here, it's kind of very hard to read and figure out what is really going on my system. So this is where the scaling parts comes into play. So Audit is a great tool to collect a lot of low-level system events, but what do you make out of that mess of all the events that you have collected here? So let's see what we have here. So before we go any further, one thing, in case you're kind of confused, what do I even have in all my logs here? For example, the Red Hat documentation on those is pretty good. If you head over to the Red Hat Enterprise documentation, it will explain to you, for example, it has full examples of, these are some example calls they have, and they were just describing what all the different pieces and parts in there are. But we don't want to dive too much into the low-level details. Let's just say, like, it's collecting a lot of stuff, but it's kind of hard to read, and it's a bit complicated, and it's very hard to parse as well. And oftentimes you want to centralize that information, especially if you have lots of systems. You don't just want to have that sitting around on one disk. You want to kind of centralize and figure out what overall is going on in my system. And if you want to look at more rules, because you want to fine-tune your system a bit more, in the GitHub repository of Audit, you have actually a lot of rules that you can look at. For example, here you have the base config rules. Those are applied by default normally, is you don't have any rules. You set some buffers, and then you set some failure modes to collect stuff. But you have lots of other rules here, for example, to say like, oh, I want to see what is happening on the network here. case that is readable, you can see this is what the configuration would look like to collect anything that is happening on a network. So always on exit, run on a 64-bit architecture when you have accept or connect one of these two actions, and lock that thing under a key that we call external access. And afterwards, you could search for everything under external access because that has passed through that rule. There are lots of examples in that repository where you can see different things that you might want to collect. For example, power abuse, when somebody abuses their sudo privileges. We'll get back to that example a little later on. If you have any container actions, like somebody starts a container, and lots of other things, here are the examples. This is what you can try out and run then. Okay. So, speaking of namespaces, by the way, those are still a bit work in progress. This has been split up into multiple subtasks. Figuring out which user has been doing what in what container is still a bit tricky, but Audit is in the process of adding all the enrichment and figuring out which container or namespace has been doing what. But that's still a bit of a work in progress. Okay, so we want to collect all the things, basically, and ideally we also want to centralize them. Now, how do we do that? Yeah, how do I collect that? Well, we could just take the files and collect all the files and then try to parse the files, but that's still sometimes painful. By the way, why am I talking about that? So I work for Elastic, the company behind Elasticsearch, Logstash, Kibana. Some of you might use us for various use cases, either logs or also security-related events. And I generally just talk about the stuff that we do in that area. So this is a highly monitored, like Hello World application of Audit that we want to walk through to see how that is all fitting together. So lots of you are probably familiar with that one called Elk or Elastic Stack. Nowadays, we try to call it the Elastic Stack because, well, we have added a bit more. Because we have Elasticsearch to store everything, Logstash to get and parse the data and enrich it. By the way, any idea what enrichment could be? Like, for example, you have an IP address and you want to get a geolocation of an IP address. That could be enrichment. That normally we do that at ingestion time when we store something, so that queries will be faster afterwards. And then we have, for example, Kibana to visualize what is going on or what we have collected here. The only thing is, Logstash is sometimes a bit heavy because, well, it started off as Ruby and is now JRuby, and I know just to collect events, normally people don't like the JVM to collect their events. So we figured that out, and at some point we added another component called beats. And well, then we tried to come up with this new acronym called ELK-B or BELK, which could have looked something like this. But we didn't really stick with that because we're always about scaling, and this is not very scalable, because what happens if we add another open source component to it? Then we'll get another letter, and it will get very hard to make up another animal. Whatever the next letter will be, it will be very hard to figure out some other animal. Even though the elk-B, the bee with the elk horns is kind of cute, we got rid of that, and now we just call it Elastic Stack because that's scalable. Whatever you have, just stick it in there, whatever new products we add. And this is the general architecture that you can use there. However, we only need 3 components for today. We'll use the beats, which is like a lightweight agent or shipper written in Go, so you have native binaries, so you can forward your data. Then we put it into Elasticsearch to centralize it, and then we have Kibana to do some visualizations on top of that. And all the stuff that I'm showing you now is open source and Apache 2 license, so you can just take it and do whatever you want with that. So, the first thing that we tried, and I wouldn't say we failed, but it has severe limitations, as you'll see. The first thing that we tried is we tried to build a so-called FileBeat module. And the FileBeat module is basically taking whatever Audit D, the log file, is creating. So when you look at the raw log file, those are also stored in a log. And that's var log audit or audit.log, if I remember correctly. So these are the raw events. Like, it's the same thing as if you were doing all search raw. You have the same thing in a log file. And we tried to collect those, and this is kind of working, but parsing this file is a pain in the ass because every line is looking different. Like depending on whatever type you have, you need to make sure like how many attributes are coming afterwards and how to split those up. You can do that, and we have done that, so I can quickly show you what this looks like. If you've never seen Kibana, this is Kibana. I'll just stick to the pre-built dashboards. I'm lazy. I didn't build those myself. You can be lazy too. So what I'm interested in is FileBeat is basically, FileBeat is the thing that tails log files, and it just collects log files. And at some point, we figured out maybe there should be modules to collect common things, and we call those FileBeat modules. And basically, those are for Nginx or Audit-D or Apache or MySQL and lots of other formats. We basically know on this operating system, which I'm using Ubuntu, the log file for Audit-D is in var log audit audit-d.log. And then we know approximately what the standard log format looks like. If you change that log format, you will obviously need to customize that. But we try to figure out what you have. Basically, you just say like, I want the Audit-D events, and then the beat will figure out, okay, this is where the file is, this is what the file should look like. I will try to take that, parse it, and just store and centralize it. And well, the auditing events that we have parsed look something like this. So I didn't collect any from the file recently, but for example, if I head over to the last 24 hours, you can see these were all the event types. You have seen some before. For example, we're changing a directory, or we're running a system call, or something is happening on a path. So we have the event types. We can see which users have been doing something. And you can, for example, see, okay, this is how many events were successful or unsuccessful over time, and you can also see where they have been coming from. So surprisingly, a lot of those are from China. Any guesses what those events are? Yeah, those are SSH authentication login attempts, which failed. So for example, here, if I look in that list of users, I've never heard of that user, and I would really be curious what somebody has been doing here. So if I filter down on that one, you can see, okay, it was just authentication tries that somebody tried, and there was pretty much a spike here when somebody tried to use that user, and you can see somebody from China tried to log in with that user 6 times in a specific time frame, and you can see here where and when. So this is all kind of nice, but it's also slightly limited. By the way, some other stuff that the FileBeat modules can collect for you is, when did somebody run a sudo command? That might also be interesting. So in the last 24 hours, you can see on which files did which user run sudo commands how many times. And you could, for example, see over time which users were running the sudo commands, and for example, when a user ran something that was not in the sudoers list. And well, they shouldn't have been doing that, and then you can dive into what has been happening here. Or you could, for example, take a look at, well, what was in the system logs. Obviously, there is a lot of stuff happening in the system logs, but we have collected those as well. And you can also see, for example, which users or groups were added over time. So that could also be kind of handy, that somebody created a new user here that might be kind of suspicious if you didn't expect that. And you can also see like which users have a shell or which have a no login set, and you can just dive a bit down into those details. And if somebody breaks into your system, those are all valuable things to figure out what has actually happened over time. Like, has a user actually been able to create new users, and how did that spread out through your entire system? In my example here, okay, I remember that I have been doing that. Okay, I created an NTP user and I created a group developers. So that was me. Nobody else has been creating groups, but you're never sure what happened on your system. You can also see, for example, the SSH login attempts. Over the last 24 hours, filter down on those, you can see most of them actually failed. And you can see this was me when I was doing some stuff today myself. You can see which users were most popular to try to log in. And when you zoom out, you can see, okay, China was definitely leading. Normally, I either see Russia or China first. But today, the Russians seem to be taking the day off. Only China are active. I'm, by the way, very disappointed that we don't have more login attempts from Finland. This is an online system. You could just try to do stuff, by the way, and we'll hopefully figure out what is happening. But please don't run a denial of service attack against it, otherwise the demo will kind of be not so much fun anymore. But yeah, let's see if later on we will have more login attempts from Finland. Okay, so this is what we have been extracting. However, it turned out over time that this is kind of a pain to parse, like I said. And we also have this thing where we need to dog food or eat our own dog food, though most people don't like that dog food thing. We normally prefer to say like drink your own champagne because it sounds much fancier. We had that moment where we had to drink our own champagne a bit because we have a cloud service where we provide our services as a service. And they said, well, we want to get all these security events and well, we have the right stack, why are we not collecting that? And that basically led us to reconsider how are we interacting with Audit D and what we could do with Audit D. And basically what we did is we created another beat because beats are basically a framework and it's called the Audit beat. So what we're doing is we're reusing what Audit D is doing and we're using the same syntax. We are just collecting that directly and we make it easier to correlate events, resolve the user IDs and the user names. We have a native integration into Elasticsearch so we don't write out that weird file that is a pain in the ass to parse back, but we're sending stuff in a structured format off the machine right away. We were considering eBPF for some time. The problem was we have a lot of users and also internal use cases which had older kernels, and eBPF didn't give us all the stuff that we wanted on those. So Audit D is kind of like a stopgap and giving us a lot of the features that that eBPF is also providing. It's just that Audit D works with older kernels, and well, we wanted to use those. We think that all configuration is a bit easier, and well, you have Go binaries, so it makes your life a bit easier for that as well. So, and it also does full Docker metadata enrichment. So basically, whenever you run a command, it comes from a namespace. We will run a lookup against the Docker socket, if you have access to the Docker socket, obviously. If you have access to the Docker socket, we will then resolve what a specific container was doing, and we can enrich that with Docker, like base images, labels, anything that you have on that ecosystem, we can enrich on that as well. So, what is Audit D doing? Let's take a look. Shall we take a look at the configuration file? Maybe that's the right point in time to do that. So, like all our beats, audit beat is, well, auditbeat.yaml is where the configuration file lives, and let's jump to the beginning of the file. Basically what we have here is we have an Audit D module. We are setting pretty much the same settings that we have in the default settings, or I've applied the same settings where you see I have a backlog limit, I didn't set the rate limit, but you could set the rate limit if there are too many requests coming in, for example, as well. I'm getting rid of the raw events because it's just unnecessary storage and I want to keep that a bit slimmer. And then after that pipe, which is, yeah, everybody loves YAML, that's the way to just pass in a random message. First, to remind myself how that Audit D syntax always works, I have a comment to say that first, either you watch a file with -w, or you monitor a system call with -a and then action and the filter. And then we basically dive into that. So for example, here we're watching a file. Here we would, for example, watch the etc passwd file, and we tag the entire thing with identity. And if I scroll further down, here, for example, I watch the read access to etc passwd from a user in a specific group. We'll come back to that rule in a few moments. But this is just what the general Audit D configuration syntax looks like. So if you have Audit D running, you can just take the same rules and stick them into Audit beat, and it's doing the exact same thing. So what you get from that, what I've extracted here is, do you want to see the raw events first or the dashboard first? Where do we go? Dashboard? Okay. Let's see. We have an overview. And here, this looks pretty familiar to what we have seen before. Let's switch that back to the last 15 minutes or so. So it's not too much. You can see like which actions have been running here, somebody executed something, somebody logged in. You basically see over time how many of these events have been happening. You can see which event categories you have been collecting here, and you see the raw events down here. But this is just combined dashboard view of the raw events that you have. So if I head over to Discover, these are basically the raw events that we have collected. And for example, for Audit Beat here, these are all the things I'm collecting here with Audit Beat. I see that in the last 15 minutes, so the last 15 minutes, this is that one here, I have collected approximately 800 events on my system. And if I unfold one of these, you can see, okay, somebody seems to have tried to log in with an invalid user from that IP address. And you can also see some other nice information here. For example, something that we automatically can enrich is the host information. So I'm right now enriching every event that I'm collecting with the operating system. So you can see here I'm running on the latest LTS of Ubuntu. You can see some internal IP address, the host ID, so you can backtrace that to the instance. Or for example, if you know that some specific security issue is just affecting one specific operating system or one specific version of the operating system, you could just filter down on that here. So for example, if I would click on that plus, I would only filter down to my Ubuntu 18.04.1 instances. However, since this is the only operating system I'm running here in my example, we have all the events collected here as well. So we're not really filtering down on much. But if you have a fleet of operating systems, this would be the easiest way to filter down what operating systems do you even have running. And then I'm also enriching the cloud metadata. So you can see my stuff is running here on AWS in EU West 1A. So EU West should be Ireland. In the 1A availability zone, you can see the instance ID. You can see this is running one of the cheap T2 micro instances. So you can filter down easily on the region or the cloud provider or the instance ID. And you can just see where stuff is happening in your system. This is just things that we have enriched. And you can see here something has been happening with SSH, and an unknown user seems to have tried to log into our system. So these are the raw events. Okay, let's see what else we can do here. So these are my configuration rules. Let's log in with another user. Let's take the Elastic user first. So the first thing is if you fail to log in like I'm doing right now, we should be able to very easily track that down. Where did we find that information again? We had a dashboard with the SSH user, so let's try to find that user again. So if I head over to SSH, I know which user I'm looking for. So we didn't have any successful login attempts, but I'm trying to log in. Okay, the usernames are getting a little more colorful now. But I'm interested in my Elastic user, and well, that has only been happening from that IP address. Let's quickly check with my VPN. Yeah, that was me. I failed to log in. That's correct. And since I'm roaming through my phone and have the VPN on, it also looks like it's coming from home and not Finland. Okay. So let's try that again, and this time I'm logging in with the right password. And now let's see what my user could be doing. So for example, let's say I have Nginx running and I want to restart Nginx. And well, since I don't have sudo privileges, I will need to pick a user and actually run as that user. And I hope I remember that correctly. And we have just restarted the user, the Nginx process. So let's see if we can actually trace that in our processes. So we have another dashboard here for audit, if I could type, Audit Beat, where we have executions. And in the executions, I know that the Elastic user has been doing something, so I will filter down on that user. You can see overall, these were all the commands that that user has been running in the last 15 minutes. And if I look here, you can actually see, this is what the user has been doing. There have been some other things being run under that user, but this is the event that I'm interested in. So if you open that one up, you can see, okay, this was the actual event, and you can see the Elastic user started this command and was running that. Then you can see all the other information about the operating system, and what is more relevant is, okay, this was the Elastic user who has been running that, and you can see the user groups, and you could even just find the raw events around that. For example, if you would have too many events here, if you have lots of things going on in your system, maybe just running on the user itself is not enough, but we could, for example, filter that down just with the regular full text search, and then you would have a single event, and then you can see, okay, this is what my user has been up to, and this is the actual event, or the stuff that that user has been triggering here. And it was actually a successful event, so we have been able to restart Nginx. Or, for example, we could say, my user is just trying to poke around the system. For example, we could say, etc passwd, I just want to take a look at which users do I have in my system. And for that, for example, we have created a dedicated rule that we have mentioned before. So this is the rule here. So basically what I'm saying is, if somebody is reading the etc passwd file, and the user is from the group with the ID 1001, which that specific user is from, then we want to log that with the tag developers passwd read. And to find that actual event, what we need to do is, well, we can head over to the raw events. And then we could, for example, say we have the tags is, and then we have exactly that tag that we have just specified. And that way we could filter down from my 2,000 something events. We would see in the last 15 minutes, these were the events with that tag that have been caused. And if you scroll further down, you can actually see what has been happening. So you can see here, bincat has been called on that file. So the object primary, that's always kind of like the target on which you run something. You can see we have opened the file, and you can see which user has been running that, and you can see all the attributes of that user, and you can see, well, it was the Elastic user, and you can see that was the group ID which we have been filtering on. So that is what that user has been up to. Let's try something else. Let's say this user is logging out, and we have the admin user now. And we kind of have a curious admin user. And that admin user is just poking around the system, abusing their privileges. So for example, we take a look at home, and then we see, okay, we have our own home directory, but we also have the Elastic user directory. And we'll just start looking around, and then we see, oh, we have a file called secret.txt, and obviously we want to look at what that secret.txt is doing. So let's have a look. Will this work? Obviously no, because we missed the privileges. If you could type. And you can see the file contains my secret. Now, this is clearly abuse of the privileges of sudo. Like, that user shouldn't be poking into the private directory of any user. So how can we collect that with audit-d? So let's look. Luckily, we have created a rule, and this is the rule we're interested in here, which we have called the power abuse. So if we have a user ID for a root user who is looking into stuff from a non-root user, so these are the regular users like my Elastic user, which has the group ID 1001. So this is clearly in that rule, and basically we want to log that when you try to access a file owned by a user of that 1000 plus group. We want to log that under power abuse. So if I head over to my raw events again, I want to edit this, and this should be called power abuse now. And if you're lucky, it was the very latest event that we have here. And you can actually see, okay, the Elastic admin user has been running cat on the home directory or the specific secret.txt file of that user. then you could ask the user, was it really necessary, or are you maybe abusing your pseudo privileges? And there are some other things here. Not everything is really a security thing or some active power abuse, but some of them might make sense to look more into them. But I mean, landscapes is saying, okay, this is probably less harmful. But for example, everything in the home directory, that is something where you might want to take a better look at. So for example, you could just filter down on the home directory and just find all the events where somebody used their pseudo privileges to look into stuff into the home directory. So that would be possible as well. Okay. One other thing that we have added to, that is not part of Audit D, but we have added that to Audit B, is we have added a file integrity check. While the Audit D stuff will only work on Linux because, well, it depends on the kernel features, the file integrity works on other operating systems as well. Depending on what operating system you're using, we will use different mechanisms to check that if a file has changed. So for example, on Linux, every time a file changed, you can do that with inotify. On macOS, it's fs events. And on Windows, it's read directory changes w. And with those, we basically can monitor one directory to see that if something has changed. So for example, let's take a very simple example. Let's say we have our website, and this is working fine, and somebody might be abusing your website and adds a file var HTML index. No? Not like this. That's much better. So here we have a very simple website, and if I would see my cursor, let's say somebody is changing your website, and let's do something like this, which is maybe not what you want on your actual website. So if somebody comes to your site, they will now see. If this is happening on your company website, you're probably not too happy. And maybe you want to figure out, like, how did that change happen to my site? And that's what the file integrity module, or where that comes into play. So let's see what we have configured in the file integrity module. So if I scroll further down a bit here, besides the Audit D module, we have this file integrity module. And I can configure which files or paths I want to monitor. So var www HTML is what I want to scan. You can define like how much data you want to scan or what is the maximum file size. That is mainly not to take up too many resources on your system. And you can also say like, which hashing algorithm do you want to use to figure out which files have changed. SHA-1 is the default. We have a couple of others. I'll have those in the next slide. So you can figure out what is happening there. And then we can actually head back to the dashboards to see if we can find what has been happening here. So here we're interested in Audit Beat. And we are interested in the file integrity. And we can see, okay, 3 files were created, updated, and changed. You can see when that happened. You can see which user was responsible for that change. And here you can see which files were most edited or changed. Since I was using VI, well, we have the swap file. And that's why we don't have just one file, but we have multiple files being edited. But that's just how VI is handling files. But this is basically tracking every single change that we do to that directory. And it's hashing the files. And thanks to that hash, we can just figure out who has been doing what to a file. And then you will probably see why suddenly your website has hearty emojis on it rather than the actual content that you want to have, or probably stuff that is worse than hearty emojis. And you can see, okay, on which host, how many change events happened. This will be useful if you have more than one host, and you can see which files, what happened to the files, like were they moved, deleted, updated, like all the operations that were being run on your files. You can get the idea of that here. Okay. yeah, these were the hash types that I promised you. So SHA-1 is the default, which is, we think, a decent trade-off between speed and like a good hashing function. To get the most performant hashing function that we have is the last one, that's XSH64. That is the most performant hashing function that is part of the file integrity check. Okay. Since we have some time left, let's try something else as well. Let's talk. Let's say netcat l. Anybody wants to send me a message? Or do I have to talk to myself? Let's see, telnet. And ideally, here our messages will appear. So if anybody is quick enough, telnet or anything else will work to send messages. How can I find that I've opened another port or been running a program to figure out that somebody has been opening something and maybe they should have been doing that or shouldn't have been doing that? Any guesses where to start? Let's head over to the raw events again. I'll get rid of the filter. You can see we have 1,600 events in the last 15 minutes. Let's say you know that something happened on a specific port. And well, we have no idea where to start. So actually, I will just start with the full text search. And if I just start with 1025, since we are logging all the system calls, every time a program has been running, we can actually very easily see, okay, which user has been running what program and what has been happening. So you can see this was the user that has been running the process. So the Elastic admin has been running that. And this was the actual command that we have been running. So netcat l1025, so people can actually chat with me. And nobody wants to talk to me, which is very sad. But this is just how to get started on that. OK. We have seen the file integrity. By the way, if you have lots of events, something that might be very useful is that you don't just have static filters, but that you have something that learns automatically kind of what is happening on your system, which might look something like this. For example, these are, let's assume the unique IP address is connected to your system, or the users logged into your system, or whatever you have. And you probably have some pattern where you see 5 weekdays, and then you have the weekend where there's less activity, and you want to find anomalies, like when something unexpected is happening, like here, which is kind of hard to see, but if you zoom into that, you can actually see here the blue band. This is kind of the expected baseline. And here's something unexpected happened. This is from our own website, the unique users on our website, and that was 1.5 years ago, or almost 2 years ago when Amazon S3 went down. But this is just how to figure out when unexpected stuff happens on your system, and especially with Audit-D, which can be a bit noisy and creates a lot of events. Creating rules manually is often a pain in the ass, and having some machine learning to actually learn what is happening on your system normally can be very beneficial on that end. Okay, so to wrap up and have some time for questions, I always compare this entire thing a bit to Lego. You have all these building blocks, but you need to stick them together. So you need to start with the Audit-D rules, like which Audit-D rules make sense. If you need inspiration, like I've mentioned before, here you have a lot of rules that you might want to take a look at and which can teach you what is possible or what might make sense. And then you need to figure out how do I get or centralize those events. We tried to provide a solution for that, but you can also try to manually collect it and use all report, for example, to see what is happening in your system. Yeah. And we've basically seen going from Audit-D to the Audit Beat and then integrating that with logs and other dashboards and just seeing what is happening to that system overall. That's the general idea. If you want to try that out yourself, you can go to Dashboard, and I think you should be logged in automatically with the dashboard-only user. So you will not be able to delete any data. You will not be able to create any new visualizations, but you get to the default dashboards. Let me actually try that out if that works as I'm expecting it to work. hopefully. So you should be logged in with a user automatically that doesn't have too many permissions. If you load, this is now the demo effect. Come on. No? No? Okay. I will check if I have misconfigured my dashboard user. No, it's working. It's just slow. And if you log into that, you will not be able to create any new visualization. So you can see I have a lot of more buttons here. But you will be able to, for example, to here see which executions have been running or which SSH users have tried to log in. And I'm not giving you the root user, but if you want to play around with it, this is the password and the user for the regular access. So you can just log in and try some random stuff. And see if you can find that in the events. And I will delete that instance tomorrow morning. So yeah, there shouldn't be too much harm you can do, but please don't abuse the instance too much. By the way, I wanted to check, do we have more SSH login attempts from Finland now? Let's see. And let's see how good our GeoIP lookup is today, because that's always the question. Seems to be pretty decent here. Yeah, okay, more or less. You generally get the idea. If I'm not mistaken, I think we are about here or so. We are slightly off, but at least this looks generally correct. I'm curious. That's the wrong button. That's not what I wanted. Come to me. I was curious which. Let's say this is where what we're interested in. Let's filter down on that area, and then I can see which usernames you tried. Okay. And Rocky seems to be in the house as well. So these are the ones, the 27 login attempts that you have tried from this area and whatever your IP addresses are. Okay. If you want to take a look at the code, I mean, this entire setup is automated. There is the Terraform stuff and the Ansible configuration and then the configuration files. The thing that you're probably most interested in is the audit beat configuration, which I have in there as well. So this is all part of the repository. You can just head to the repository and check it out if you want to give it a spin. And this should be pretty easy to reproduce on any other system that you have as well. So that's the URL for that. So if you take the code from there, you should get this up and running in pretty no time. And with that, we have like 11 minutes left. Time for questions. Also, I have a bunch of stickers over there. If you want to grab stickers, be quick. There might not be enough for everybody. Any questions in the room? Otherwise, I will head to Slido. And I have a very hard time seeing if anybody has questions. I think we have a question over there. Thank you. And while you're getting the microphone, let me head to Slido as well, so we are not overlooking anybody.
It's great to see some more open versions of this sort of technology, but there's a lot of commercial software doing the same sorts of things. A lot of people who work in security operations centers will be familiar with things like Carbon Black. Krenn Micro have Deep Inspect. There's quite a lot. How do you feel that this currently compares with what's on the market from those commercial vendors?
So we're generally, let's see what I can say now. Let's just say like security will be a big topic for us, and we see that as an opportunity to dive into lots of other things. I know that we are being used for SIEM-like use cases already. We'll probably try to get a bit more into that space, but it's a very wide ecosystem. And obviously, there are a lot of other vendors and a lot of commercial vendors which have quite a head start on us. So we'll have to do some catching up to do. But we'll try to do our best. And we're also trying to integrate with some other tools. For example, if you head over to the very first start page here, you can see we are trying to get more security analytics. And the 3 things that we are advertising here is, generally, we can get NetFlow data from your networking devices. We tie into OS Query. Though probably we will have some native stuff that is very similar to OS Query in the beats as well soon. And we're playing around with the Suricata logs as well and try to integrate into those as well. And generally, I mean, this is always the nice position that you can take in open source, is that whatever you want to build, you can do it yourself because you have all the code and you can just integrate into that. But like I said, with the Lego bricks, it's more like stuff that you need to put together. We're not like the solution that you buy and that's kind of the final thing and it just works out of the box. It's giving you a much wider range and you can integrate it in various directions, but it's probably a bit more plumbing necessary. But I would assume that you're the right audience for plumbing.
Don't get me wrong, it's better than some of the commercial solutions I've seen by a big stretch.
Thanks a lot. Any other questions? Okay, while you can think about that, let me head over to the 2 questions I have seen here. Okay, bottom one is very good, thank you. Yeah, we have a file beat module for OS Query. So if you have OS Query installed, you can collect that. So let me just quickly show that file beat module OS Query. Basically, when you run OS Query, it can create the logs, and then we have the file beat module, which can automatically collect that log file. So depending on what you have activated here, it will look something like that, where you see, okay, these are my operating systems, these are the kernel versions, these are all the packages that we have. But we will also soon enough have something where this will be built into the beats directly, so you don't need to run OS Query yourself. But if you want to run OS Query, you can totally do that. Just generate the right logs with OS Query, and we will happily collect those, and we have even the pre-built dashboards for you, so you can just keep using that and get an overview of what you have running on your entire fleet of machines based on the OS Query data. I think that was it for the questions here. Any other questions in the room? We have still 7 minutes left. I have a very hard time seeing, unfortunately.
For multi-threading applications, what's your ability to distinguish between multi-threaded applications and monitor those?
You mean distinguish between
the threat would be a threading injection attack.
I'm honestly not sure how well we would handle that at the moment. I've never seen how we would handle that, to be honest. I'm not sure. Maybe a quick search will give you something or nothing at all, then we would be curious how that actually works. But I don't know from the top of my head, to be honest. Well, if there are no other questions, if you have any other questions, also if you have like general questions about our stack, I'm here. Happy to help with anything. Just find me afterwards, and thanks a lot. Oh, by the way, before you run out, I'm not sure if that will work out. I try to take a picture with you normally, so I can prove to my colleagues that I've been working, because they normally don't know where I am. I'm not sure if you will be visible. Let's see. Smile or not smile, you don't see me anyway. Ah, that's better, thank you. Thanks. Now I can prove to my colleagues that I've been working. Thanks a lot.